Hey physics friends, and welcome to Projectile Initial Conditions, the advanced questions answer key. So what I'm going to be doing, this is a continuation of a video that we saw a different day where I was going through the answer key to these initial conditions. Now I'm going to go on to the advanced questions and talk to you how I use the numbers that I got here, helping me understand what the answers to these questions are. Let's get started. So the first question says, in problem number 1, how high does that projectile go? So I'm going to go back to question number 1, and I'm going to grab my answers, these numbers, to figure out how high does it go. All right, so here's where I'm going to get a little creative. So I want to know how high it goes. There's something very special about that place. The velocity is 0 at that point, vertically. And I want to know how high it goes. I don't care about time. So I'm going to use the equation that doesn't use time. Vf squared equals Vi squared plus 2AD. Final velocity, 0 squared. Initial velocity, 20 squared plus 2 times negative 9.8 times my displacement d. 20 squared is 400. 400 divided by 2 is 200. 200 divided by negative 9.8 turns out to be 20.4. So this letter D, 20.4 meters. That's how high this thing ends up going. Pretty cool. On to the next one. In problem number 2, how long is that projectile? How long is this projectile in the air for? So we're looking for the time. So I'm going to use this point right here, and I have to understand something. That when I find the time using these things, that's half the time. When I use the final velocity equal to 0, that's going to be half the time. Vf equals Vi plus At. 0, initial velocity 17.3, the acceleration negative 9.8, time. So when I take 17.3 divided by 9.8, I end up with 3.53 seconds. No, I get 1.76. So then I have to multiply this by 2. So 3.53 seconds. Here's another way to do this problem. Instead of using this point right here, now I could use this point right here at the end. At the end, the projectile is going forward still at 10, and now it's going to be going down at 17.3. So I could use a final velocity of negative 17.3. And I could do this problem again. Vf equals Vi plus At. Final velocity of negative 17.3, initial velocity of 17.3, acceleration negative 9.8, t. So when I bring that over, it doubles it immediately, and then when I divide that doubled by 9.8, I end up with t equals 3.53. No doubling necessary, because I used this point. So you can use this point. Just remember to double it, multiply by 2, because that's the time it takes to go the whole way. Or you can use this point, and there's no doubling necessary. In problem number 2, how high does that projectile go in the air? So I'm going to paste that same work that I had before. How high does it go? Ooh, how high it goes. I'm going to make sure that I use this spot right here, because that's how high it goes. And I'm going to solve it for the displacement. So again, I'll use the equation that doesn't involve time. So Vf squared equals Vi squared plus 2Ad. Final velocity vertically is 0. Initial velocity 17.3. Solving that for the letter D, you end up with 15.3 meters. So it goes 15.3 meters in the air. Next question, number 4. In problem 3, how far from the base does the projectile land? So here, this one's looking, how far from the base is this right here? You're looking for a horizontal displacement. Now, the only way to find the horizontal displacement, we're going to use velocity is equal to distance over time. My velocity is 20. I don't know my displacement, so I have to figure out the time. What I'm going to do is I'm going to use all of these things on the right-hand side to find my time, put my time in, and I'll be done. So let's use this stuff over here to find my time. I'm going to use the one that doesn't involve final velocity. So d equals VIT plus 1/2 AT squared. So vertical displacement, -10. Initial velocity is 0 because I'm not firing it vertically anywhere. 1/2 the acceleration, -9.8 t squared. So I can solve this for t, and I end up with 1.43. Mr. Hare, do I have to double that? When do I double it? You don't have to double it in this case because you're using the displacement from here to here. So that's the whole displacement. So that gives you the whole time. So this time is completely valid. I'm going to put 1.43 over here. And then I can solve for my displacement. So 20 times 1.43. So you end up with 28 meters. How far does it go? 28 meters from the base of the cliff. Number 5. In that problem 3, that same one, what speed and what angle does the projectile hit the ground with? So I'm going to go back to my previous problem. I'm going to grab all that work. Bring it over to this next one. Uh-oh, I'm working too fast for it. So I know a couple of things here in this problem. Number 1, I know that the final velocity, wait a second, I know that the time was 1.43. And now I know 1.43, and I know the distance is, we found 28. So when this thing hits the ground, when this projectile hits the ground, it's going at some velocity v. It's going forward with the velocity, that's the horizontal velocity, and it's going to be going vertically with another velocity. Horizontally, it is going 20 because projectiles go forward at a constant speed their entire time. Vertically, what I'm going to do is I'm going to find this piece right here, the vertical final velocity. Once I find that vertical final velocity, I can stick it in here, and then I'm going to do the Pythagorean theorem to find my velocity v, this black one right here, and then I can do inverse tangent to find the angle that it hits. So I think that I'll do VF equals, to find my final velocity, VF equals VI plus AT. That's this right here. I'm going to look for this. Initial velocity 0, the acceleration, and the time is 1.43. So if I take -9.8 times that, you end up with -14. So this equals 14. So to find my v, how fast does it hit the ground with? A squared plus b squared equals c squared. So then that velocity ends up being 24.4. And what angle does it hit the ground with? I can use the inverse tangent of 14 over 20. And that turns out to be 35 degrees below the horizontal. So in number 6 says, in problem number 4, how far from the base of the cliff does that projectile land? So I'm going to jump back, grab our work that we did initially concerning this, and then go from there. So it wants to know how far from the base does this. So this is very similar to the last one, except that there's a vertical component to this, so not really much difference mathematical wise. Let's see. So we want to know this distance again, and so that is the horizontal distance. And again, in order to find that, you're going to use velocity is equal to distance over time. And we know the velocity. It's not 20 this time. This time it's 17.3. We are looking for the displacement, so again, we're going to go after the time. We're going to find the time, but we're going to use our vertical pieces to find that time, and then from there we're going to put that time in to solve the problem. So let's go ahead, let's use all these things here to find our time. So I think we're going to use the one that doesn't involve the final velocity. So this one, d equals vit plus 1/2 at squared. Now negative 10, my initial velocity is positive 10. Time, oh boy, I can see what's going to happen already. Negative 9.80 t squared. This is a quadratic. This, no good. Negative 10 equals 10t. So I'm going to combine these two things, minus 4.9 t squared. So I rearrange all this stuff and I get 0 equals negative 4.9 t squared plus 10t plus 10. Yikes, yikes, yikes. So you have to solve this for t. Not as easy as it sounds, because you're going to have to use the quadratic formula, or maybe you can graph it on your calculator and find the zeros, or maybe you have a TI-89 like I do and it will just solve it for me. But how does your average physics student, or you could factor it. That's no fun. Nobody likes factoring. Maybe I'll use the quadratic formula, and the quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Whew! So when I do this, I have to add and I subtract. One of these is going to give me a positive answer, and I'm going to go with the plus. So it's going to be negative 10 plus square root 10 squared minus 4 times all of that stuff. And it turns out to be, let's see, 4.53 seconds. So this, 4.53 seconds. That's my time. I did all that to then find my time. This is 4.53. So I multiply that number by 17.3, and I get my displacement. 4.53 times 78. Which problem is this? 6. That's 48.1. Oops. Sorry, this turns out to be 2.78. And my displacement, 48.1 meters. The next one? That was not fun. In problem 5, how long is that projectile in the air? The time. So I want to know the time. So I think this one's pretty straightforward. Take these things, the equation that doesn't involve final velocity. Oh boy. Hopefully it's not like the last one. I'm feeling it is. Displacement, negative 10. Initial velocity, 20. T plus 1/2, negative 9.8. Oh, son of a gun. So I'm going to combine these, negative 4.9 t squared plus 20t plus 10. So this is basically the exact same last problem. Let me show you a way to do this sort of problem where you don't have to use the quadratic formula. So what I could do is I can sidestep the quadratic formula if I found the final velocity. So what I'm going to do, I'm going to take the long way around. I'm going to find the final velocity first. So let's ignore time for right now, and let's go VF squared equals VI squared plus 2AD. Final velocity is unknown. Initial velocity is 20. The acceleration, negative 9.8, and the displacement is negative 10. So 400 plus 196, 396, no, 596, square root of all of that, you end up with 24.4 negative, because it's going down. And then I can use this equation, VF equals VI plus AT. Final velocity, negative 24. Now, if you forget that negative, you're going to get this wrong. Initial velocity is 20. The acceleration, negative 9.8 times t. So then I bring the 20 and I get negative 44.4. So negative 44.4 divided by negative 9.8. You get your time of 4.53 seconds. So I was able to find the problem. Even though I encountered the quadratic formula, you can do a sidestep where you find final velocity, and then from the final velocity you can find your time and never have to use the quadratic formula. Number 8. Problem number 6, with what speed does that projectile strike the ground? With what speed does it strike the ground? So this, as it's traveling, you fire it, it hits the ground. It wants to know with what speed does it hit the ground. So what we really ultimately need to know is we need to know how fast is the velocity horizontally, and we want to know how fast is the velocity vertical. So horizontally, the velocity is the same as it was at the beginning, 17.3. Vertically, it's this right here. Whatever this is, that's the vertical component of the velocity. We'll end up doing the Pythagorean theorem, a squared plus b squared equals c squared, to find our final answer. So let's find VF. So I think we actually found it in the last problem that we did. Initial velocity is negative 10 plus the acceleration. Oh boy. And the time, oh man, I think did we use this in the last problem? No, we didn't. That's brutal. Let's do a different equation. VF squared equals VI squared plus 2AD. Final velocity is unknown. Initial velocity is negative 10. The acceleration, 9.80. And the displacement is negative 10. There, we can do that one. So that's 100. And then 2 times 9.8 is 19.6. And then times 10 is 196. So this is 296. Now be careful. When you go to do this, final velocity, the square root of 296 is the negative. Remember, like the square root of 9 is 3 or negative 3. The square root of 296 is going to be negative 17.2. So, oh wow, that's kind of fun. It's almost the same. So then to figure out our final velocity here, you're going to do a squared plus b squared equals c squared. So v 17.3 squared plus 17.2 squared, your velocity ends up being 24.4. On the last one, in problem 7, how long does a projectile take to strike the ground? We're looking for the time. So, let's roll here. My displacement, -10. Initial velocity, -20. Oh boy. And this is a quadratic formula one. Again, you could sidestep it by finding this and then finding time. I'm just going to go right with the quadratic formula because it doesn't scare me. So adding these together, so I get -4.9 t squared minus 20t plus 10. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So you do that and you end up with 0.45. seconds. It's not in the air for very long. It's hitting the ground right now. Thanks for watching. Hope you picked up a few tips.